Alright, we'll go ahead and get started. The cam follower is kind of our final project. Figure that there's enough, but not, hopefully not too much. We have enough components to go through and put some dimensions on, get into enough coverage to see all of the GD&T. So the intention was to have a video last night, except when I started adding fasteners, the base started jumping around and I wasn't real happy with the outcome. So after making corrections, I added a few more pieces, found out a few more things about the stack up. One, that the spring doesn't appear to be long enough, and then I didn't really see any point of making the what do they call that? I'll find it, the molder, as wide as it was. So I modified it and shrunk it down a little bit, and as wide, the 30 millimeters wide would have either contacted or it would have prevented it from rotating. So that's one of the issues with this piece, is right now there's no anti-rotation, something to keep it from walking around. So I think I put that into an angle just to illustrate. So if we edit the feature, you come back and I'll tell it it's 10 degrees and it flips over. That's nice. All right, so it's able to, basically walk around however it decides to on that face, because we haven't taken care of rotation. So when we talk about degrees of freedom, that's one of the items that we're trying to constrain. So rather than making it more complicated by adding additional pieces in geometry, we're going to say that something up here or something contacts, and that is a future design revision. So at this point, what I want to do is the only thing that was really not in either of the videos was the creation of the follower, or the striker, whatever I'm calling it, and the post. And the one thing I wanted to throw in there was a spherical radius, so I went ahead and put kind of a contact point at the end. Okay, so at this point, I think the design is, well, for our purposes, complete. It was done in 2017, so at this point, oh, I already updated. I had little explanation points up here telling me that it was a previous version, and then when I saved it, it was going to update and overwrite. All right, so I kind of suspect that was the problem I had with the multi-body part and adding fasteners at that level. So the one thing to keep in mind, and I did it on purpose, is that I put a lot of noise in here. So the things that you are not concerned with is the fasteners, the washers, the what do we call that? The compensating, where the shaft coupling, the compensating coupling. Those are all purchased pieces. Anything that has a McMaster or came from the toolbox is not in our sphere of influence. It's not something that we're concerned about. It is eventually going to be part of the stack up. There's a motor that attaches out here. There's something else going on. So we have to be aware of those items and their tolerances, just like we had to be aware or think about what's going on with the bearings. So the bearings and the housing and the stack up and the retaining, and going through that process of the assembly, that is the concern. So I can't emphasize enough, depending on what level you're dealing with this model, as the engineer, figuring out what the load is on this spring and what the life cycle and what we can expect for the duration, all the way to, I'm manufacturing this 2-pound chunk over 4-pound chunk of stainless steel. As this video progresses, because I do intend to take this over onto SolidWorks for the 254 class, putting a frame underneath it, possibly. The reason I wanted the spherical is that I'm thinking there'll be a little rocker arm that comes out and does something else. So it'll be like one of those little birds that drinks the water and goes up and down kind of thing. No. And then we'll find either an AC or DC motor out here. And so I went with an oversized coupling, but I don't know if the coupling's too stiff. Right, so as this starts to slow down, or as the motor starts to slow down and it has to overcome this rotating mass, this coupler is intended to take up some of that compliance, not to necessarily be a brake, but if the motor comes to a sudden stop and all of that momentum has to go somewhere, this allows enough compliance that it's not going to, basically tear out the guts of the motor, at least not immediately. All right, so one of the things that we'll go through is I'm going to create the drawing, and then I'm going to zip this this package up. And I didn't realize that I didn't have the sheet, so we'll do it in the 2018 education version, and then I'll upload this to up to Canvas for you guys, so that you'll be able to download these items and do the extraction. And then your task is to apply form tolerance, profile tolerance, positional, the TIRs, the run out and total indicator run out, and basically go through and do the kinds of analysis. I'm really interested in, because I haven't ever really applied the fits, the running fits, the clearance fit, the locational fits, the transition fits. It is enough to give you fits. Now, really, there's all these things running in the background that we kind of take for granted that we've, I guess, is instilled as part of the build process, as the design or on the manufacturer, of what those clearances, allowances, interferences mean. But when you get into the H values, the whole basis, shaft basis, that really is another conversation. So I don't want to take it that far, but I am interested in applying it, because that seems to be something that is, like cultural knowledge or, industry knowledge, but doesn't really get explicitly stated. So find a better way to state it, and we'll bring it into the to the mix. All right, so let's see, do I have anything else open? All right, so I want to create a drawing. I'm going to use the landscape template that we had. On the previous one, the picture wasn't, the logo wasn't coming across. At this point, I don't really have a preference. If everything else comes across as I add the sheets, then we'll call that fine. And so the other noise that I threw at you is, the first instance was a multi-body part, so the -MB. That has all of the geometry for that base. And then it gets mixed at a subassembly level with the bearing housing. And then the bearing housing gets, at the next level, integrated to the shaft, and then the shaft to the follower. All right, so what I need is the base, and we'll create the multiple views and go ahead and see what that gives. All right, so looking at this, and this appears to be the top. So what I'm really interested in is I'm going to go ahead and add these, and this is kind of I want to say a general practice, is I will add more views than I need, and as I see what I'm dealing with, oh yeah, we got to confirm the delete over here. As I see what I'm dealing with and get a visual of what's going to be important, then I add or take away. So what I really want to see here is the bottom. I haven't added any dimensions, but I'm okay with that isometric view. So that gives us something that we can go back through and we can look at the pieces. Right, so the counterboard holes, those have pretty well open tolerances up to the plate and to the gusset. What is going to be a concern, and we're going to have to look at positional, are the two pins. We want those pins to line up and provide a certain amount of perpendicularity, or positional so that the perpendicularity stays perpendicular. All right, so add the sheet. It's warning me about my little angle, third angle projection. So I'm just going to tell it no, I don't want to rename. And then somewhere I have this open. So I'm going to kind of get that out of the way so I can just drag and drop from the base. And so let's go with the, I think it's going to be the vertical. So if I drag that in, all right, notice it's going to give you the M10 by 1.25 tap. And again, I don't really like the view it gave me. So I'm going to go with, let's see, yes. And then I think if I did that right, and one of those should be at the view. Oh, and we didn't get an isometric, so I can go into the projected view. Yeah, that was pretty much what I was looking for, is confirmation that the spot face bore, clearance bore was there. All right, so once you get this file, it is perfectly okay with me if you add views, take views away, create new views, do what you need to for the geometry. I do have one more projected. That would be, oh, that was the top. Whoops. Let's make sure I have the right view, and then we'll bring it down. Okay, so that'll give us the bottom view. That'll give us the location for the top view, and then an isometric. So if you want to rotate things, you want to move, I'll do the example real quick. If I rotate the view, and somewhere, on the other screen, we have the rotate drawing view. So if I wanted to rotate that 90 degrees, then it's going to warn me that it's going to lose any dimensions that I may have applied. But now I'm in a position to where I kind of lost my top, the location. I have to add another view over here. I don't really need that view now. Again, it's manipulating the views to get a desired result. All right, so I think we're okay with that. And no, I don't want to do the block. Oh, pictures are coming back. That's nice. Let's see. We'll go with the gusset. Oh, and so this is just dragging and dropping. I still don't like the 10. So even though it doesn't need an angular tolerance, I'm going to say this is our chance to put an angular tolerance on. So we do want to ensure perpendicularity here because that is supporting that vertical. And other than, we could have a fairly wide open angular tolerance here, but this is the only piece that I really encountered that would be able to take it. So in this case, we don't really need, let's see, how could I manipulate that? I like that view. I don't really need that view. So we'll go ahead and delete that one out. I'll go back into the projected view, pull a bottom view. Now you have locations for, and if we pull another projected, we can get the isometric in there. Other modifications you may want to make is to scale. So if this looks a little too small, you can go, wow, 1:1's so much better. Maybe a little too big. And keep in mind, under the sheet properties for this sheet, I can come up with, let's see, 1:1 was too big. How about I go 7/8? I don't know, just to throw something different in there. Didn't change it that much, but if you want some weird fractional number and it looks good, the measurements are coming off of the part model, so it's not like it's going to be that big of a deal. And then let's see, we had the cap. All right, so if the screen was a little bit bigger, I probably would have taken the tact that I would show the windows, and I would drag out of that top level assembly in here and into the part to make sure I get all the geometry. So my primary view, yeah, that looks okay, but let's see what it looks like from the top. All right, so side doesn't really help us there, and when I go to another isometric, all right, so we could pull one off to the side. I don't know, I'm okay with either one. All right, so things to look for was as we go through the stack up, is almost everything up to this point is going to have some kind of form tolerance, flatness, parallelism, at the very least, flatness on the bottom, and then a positional location to the bushing. And then let's see, if we looked at this one, we talked about the angles. We'll need some perpendicularity in there, some way to control that, probably a flatness on the base. Quite a few, I'm going to say, the front and the back. Other than where it contacts the gusset, I don't know that it's that critical. But I would need that, that we have that perpendicularity back to the base, and that everything is vertical, and then we could have positional tolerances around the holes. And we're going to look at the stack up of the bearing housing of how it fits through those parts. All right, so that should take care of those components. 1, 2, 3, 4. And no, I still don't want to rename it. All right, so the bearing housing then, you bring it in. Oh, and that one actually came in with just one. All right, so this I would like to have a section view. And I didn't really look into, that would be kind of a good question since these are internal. And I would still think, because this is a, now let me get it going here. All right, so let's go to the front, and then let me put in a section view. All right, I'm okay with that. And was that the, oh yeah, the tapped hole. So the assembly goal here, or at least as I saw it, was that you could take these 6 socket head cap screws out, loosen up the coupler, and everything would eject out the front. We'd be able to disassemble this as a complete subassembly, and and maintain it, do whatever we needed to do with it. So that's the reason that this piece actually ends up with the threaded holes. So let's get back to, so we'll need some position. And looking at the handbook, there are several instances where this could have a run out or a total run out, and these 2 faces become datums, and then all the rest of the geometry stacks up to those 2 datums. The through hole, not critical. All right, so the bearing faces, the outside diameter, if that's going to be the supporting structure, and then the outer flange just has to sit within that that spot face to make contact. All right, so I'll go ahead and leave that one there as a reminder, but we'd have some positional tolerance for the from the axis back over to the threaded holes. All right, so let's see, and then we need the shaft. Let's see, we have the cam. Oh, there it is. Okay, so one of the things with the shaft, and let's go ahead and do that. Yeah, we'll probably go ahead and project a view off to the side, and project a view up front, so you have kind of both ends. Let me go ahead and put this one into the hidden lines. So this is another one of those instances. One of the reasons I don't use hidden lines visible is this is just way too busy to decipher. What I wanted to point out was that there is a center drill, and that center drill is optional. If the manufacturing process can hold those run-out tolerances without supporting on the back side of the shaft, then don't necessarily need the center drill to support. But on the other side, let's go ahead and pull off an isometric view. And that one's a little bit big for what we're working with. So I'm going to go with my custom scale. And let's just reduce it to half. Or was it already half? Use custom scale, 1/2 scale. There we go. All right, now tuck it up in the corner, and then we're going to turn on the solid. So one of the things about having solids in drawings, if we were to print this out paper form, I just look at this as a gift to the ink manufacturers that at $1,000 a gallon, they would love if you printed everything out in solids. So I use solids very sparingly, and in this case, we're not planning on printing these. This will all be electronic documents. So in this case, these are our critical geometries. Right, so I'll go back and pull those up, but I want to remind, as you're going through and you see this, that we'll pick one of these. We have the central axis as a datum. Technically, the bearing is being supported at for 12 millimeters at this end and 12 millimeters at this end, and so it doesn't necessarily need the entire length, but it's probably as easy to go ahead and control it, or we're going to call it out as a from and to type tolerance. The other thing of note is because we have that, again, 4-pound, 2-kilogram cam out there flopping around off center, there is going to be a lot of stress on the nose of this shaft. So one of the things that I put in, it's kind of debatable whether this would be a controlled radius or not. But on the bearing model, it shows that there is an interior chamfer that would clear or not contact this radius. So we're identified those as stress risers, someplace that's going to be taking a lot of load and potentially fail. We're going to leave those 1 millimeter radiuses in place, and you'll have to decide if structurally they need to be a controlled radius or if we can stay with a standard. The keyway, we'll put a positional, and it's just a 5 millimeter keyway. Probably need to go back into the model and verify my distance. I think I have a little bit of extra because of the way that this built out. I drew the top and I just extruded it down rather than figuring out where the keyway would intersect. All right, and keyways are fairly tight tolerance. I also want to say that, let's just go with that one. So 0.2 on the inch drawing. I guess that's something else I should bring up. Your choice. Right now it's in inches. I will show you how to convert it to metric if you would rather work in metric. In conversations, I've had probably about a 1 to 3. Is one person in 3 will want to switch over to metric depending on where they're at in the engineering. So that being the case, if you decide that you would rather, since this is a metric part, if you would rather work in the metric, we can just switch to millimeters, grams, and seconds, but that's going to go to the default tolerances. So right now, I didn't jump over, so millimeters, grams, and seconds switches to 0.12, and then you would need to tell it that if you're going to utilize any dual dimensions, that it is in inches, and that you can pull that information back. So we'll go ahead and leave it inches and millimeters. And even in the inches, well, let's go ahead and change that for you so that you're in standard 3 decimal place. And then we'd have to watch out because our title block says the dimensions are in inches. So if we don't make it specified that it's in metric, we've kind of violated our basic title block rules. All right, so let's take a look at how this operates, and before I get too far, let's go ahead and update the drawing. And then this is going to be the cam follower, and I'm going to put it at the top level so that you will be able to find it first. All right, so when I zip this up and you extract, you're going to have all the documentation that I used. You're going to have this drawing at the top level, and then you'll have the sub-assembly or the assembly, the sub-assemblies, the top-down, the multi-body. And again, I want to emphasize that I put that noise in there on purpose, that you're looking in the background, that your focus is on these parts. And when you're looking at the assembly, it gives you this overall picture, but you are not responsible for every single part in that assembly. Right? So you work with the parts that you are responsible with. All right, so, I didn't change that back, so let's see if we go back to hidden lines removed. So that's a little bit more visible, or makes a little more sense to me. All right, so through the bearing housing, bearing on each end, and then one of the things is, how do you retain the cam and the shaft from not just falling out the end of the end of the housing once it starts moving. So if you open up the cam follower, again, not really concerned about the coupler at this point. Probably didn't need that much in the way of jam nuts, but the housing is sitting in here. So the flange pulls up, and it's a little bit smaller than 1.25 inches, so like 1.22 inches, which worked out to like 31 or 32 millimeters. And so that contacts the bearing across the rotating face, has enough of the geometry, and the jam nuts are then to preload and then lock in place so that we don't get that vibrational. The threaded portion is the M16x2 thread, and then again the coupler has some compliance for misalignment even. So we want to keep this the shaft in that same run out, but then when we come over to the end where the oh, that was what I forgot, was the keyway. All right, so key goes in there, but that's another purchase part. So anyway, the cam goes over the end. The button head is, if this is a transitional fit, either some interference or some clearance, then it's very controlled, but it has the run out controlled with the rest of the datum axis. And then the washer and the button head screw at the end are basically providing just enough contact to keep that cam in location, keep it from sliding off the end of the shaft, so to speak. All right, so those are our critical components there. And we'll go ahead and close that back, and that can save. All right. So we got that. I guess we're ready for the cam. And no, I still don't want to rename. And we'll put the cam in place. All right, so a little big on that one. Yeah, let's just stay with the half size. And we'll go ahead and put a projected view in. Oops, didn't mean that one. All right, so we'll tuck that off to the side. So we'll need positional tolerance for the keyway, the location of the shaft, and a fairly tight tolerance to guide the fit for that geometry. The outside, it's still basically circular, but this is some place that if this were to be modified, if we were adjusting the motion of that cam of the post, then we would want to look at this as a surface of profile. And so we'll treat it as the surface of profile in relation to the shaft and the geometry. And one more time. All right, so we got that one. Those are the assemblies. I'm not going to put the assemblies into the drawings. So let's see. We had the molder, and we'll go ahead and add. So that one looks way too small. All right. All right. So tapped hole. One of one of the things with this is the potential for rotation, that it could kind of unthread itself. So future may have a set screw that comes in from the side and captures the thread. There may end up being a lock washer. There's a couple ways to ensure, and we could always just red Loctite the thing together. The other thing of note is that the bearing that we chose, that I chose from McMaster, was not the DIN standard that was listed in the specifications. So I picked one that was a 1/4 inch shaft, and we'll stay with the pin, but these are going to need to be a press fit. We're going to slide the bearing into the slot. There's a minimal amount of clearance, so it's not going to be a lot of side to side motion, but we're going to need to press through all 3 surfaces, the side, through the bearing, and then into the other side. So we have that alignment to contend with in that geometry. All right. Other than that, not a lot of critical dimensions in this this piece. The staying on axis with the M5 by 0.8 would probably be good, so that it doesn't induce a lot of stress onto the shaft, and then the post. And then we bring the post in. Go ahead and accept that one. Wow, that's pretty big. And then we can rotate. I'll go 90 degrees. Maybe not 900. Oops, wrong one. Let's go back to 1 to 1. And then the other issue is this rides up and down that cam, and it kind of shifts position, changes the location. We have the potential. Finish my projected view here. We have the potential for another stress riser right at the end of the threads. Right, I didn't put a relief in this one. It's basically assumed going right up to the face. So that means we probably need a countersink on the molder, so that can come up and contact the face. Again, there's nothing that says that this can't unthread itself, and nothing that is keeping this from becoming a stress riser if we induce a lot of side load. Again, added the spherical radius that was not in the original specification, kind of as a future project or addition to this project. So we'll call that out, and we'll see what we can do with it for run out. All right, so I need to make sure that we actually have 9 pieces. I was thinking it was closer to 12, but 1, 2, 3, 4 in the first, and then 1, 4, 5, 6, 7, 9. Okay. There you go. So I'm gonna pause the video, and I'll zip this up. I'll upload it to your Canvas module. If you want to download it and make sure it works, or while we're in class, or let me know if it doesn't quite work. We'll get it set up. All right, so we created the zip file. I uploaded it to your Canvas course. Ended up downloading it. It went into downloads, and under downloads you'll see the follower. I would say put that in your My Documents, find someplace that is your working location, and then we're going to right click and extract all, and that's going to create the folder. So like I said, it's still in downloads. I'm just going to work out of downloads. Don't have any particular reason to change it over on this computer. We're just doing this for verification and make sure that I've given you good data. So when I go into open, well, I jump back to my original. So downloads, the cam follower. All right, so it did that second list. That always kind of annoys me with the folders. All right, so pick up the drawing, and then open any documents which have changed. All right, so I mentioned that concerned about the cross-contamination to my flash drive. Since the video is being recorded to the flash drive, I can't take it out. So one of the tools that we can use is go in and find references. And right now, everything is pointing to the downloads folder. If I saw anything that said D drive, E drive, whatever it is, then I'd want to take a serious look at what just happened as far as, you know, the search, the way that SolidWorks opens the files in the current folder and goes through that process. So it looks like I saved it at sheet 9, but you're welcome to start wherever you want to run through. And again, if you want to manipulate, change, add, take away, that is up to you as the detailing, applying the dimensions, and doing the tolerancing.